Hello, everyone, and welcome to Coffee with Caleffi. We've got an exciting topic today. The Legionella topic is something that we have covered a few different ways over the years, and we always seem to get a good crowd for it. It's an interesting one in a sense that Legionella, as far as what we do in our day jobs at Caleffi, isn't a big part yet of the basis of design for most projects that we work on. But as you'll find out today, it is very critical. And this is, we like to have fun in these webinars, but this is a pretty serious one that we've got a lot of great detail from a great presenter today to go through. But this is something that our industry should take seriously, and we'll go through kind of the details why. The good news is we have the tools to do this. The Legionella is something that can be managed if we have a plan in place, and we'll go through all that in the presentation today. So go ahead and advance to the next slide. Okay, so if you want, if you're having trouble with audio, you may be looking at a new view with GoToWebinar today. They kind of updated their software. So if you're having issues with the audio, you can log out and log back in. It may ask you to allow microphone or allow speakers or something like that if you do that. Or that would be my recommendation to close and reopen. If you want to copy the presentation, hit yes in the post-webinar survey. And then also we'll put this up on YouTube maybe even later today. This is kind of a mock-up of the certificate of attendance, if that works for your jurisdiction. Again, just hit yes in the post-webinar survey and you'll get one of those. Hydronics 34 is out now on hydronic balancing, and we're working on 35 currently, so we're in the editing phases of that. It'll be ready for a fall release, also available on hydronics.caleffi.com with some additional features and videos and searchability across issues. Next month, we're going to have John Siegenthaler back. He's going to be talking about hydronic heat pumps and thermal storage. So that'll be an exciting one. 90 minutes for that. So come back in September for that one. I'll put the link in the chat in a second. And today we are joined by Bruce Miners. He's our special guest who is going to cover this topic in a lot of great detail. So he is the Legionella and Industrial Hygienist at the Wisconsin Department of Health Services, Division of Public Health's Bureau of Communicable Diseases. He has extensive experience with the ASPE Legionella Design Guide Committee, the IAPMO Water Demand Calculator, Healthcare Task Group, IAPMO Construction Practices for Potable Water Systems Committee, and the IAPMO International Plumbing Design Group. So he's the guy to go into a lot of detail about this topic. We're happy to have you, Bruce. So take it away, and we'll keep an eye on the questions for you as you're going.
Well, hello, everybody. Thank you, Caleffi, for having me on. I have a lot to present today. Normally, I teach this stuff for 3 hours. We're going to compress it into about 50 minutes here. So again, my name is Bruce Miners. I'm the Legionella Industrial Hygienist with the Department of Health Services. I work on a Legionella team, and part of the team is there's 2 full-time people on our team, and Frances Golio and myself. Frances Golio is our surveillance coordinator. She works with the CDC, other states, a lot of travel, Legionella, people coming in and out of the state, so there's a lot of tracking that needs to be done. Anna Kotarian used to be the surveillance coordinator. She did everything when this program started. She has moved on to be an outbreak response epidemiologist for the division, but she is still actively involved in all our cases. So she's wonderful. And then we have Riley Marichek, who's a limited time employee. She helps out Francis doing interview support. My background, I'm a master plumber. I'm a designer of engineered plumbing systems. I'm a commercial plumbing inspector. I'm a certified cross connection. And I also worked, I was 21 years out in the field. And then I spent 15 years at the Wisconsin Department of Safety and Professional Services as a plumbing plan reviewer, as a plumbing and public swimming pool consultant, inspector, and healthcare was my specialty when I was at DSPS. I also did industrial hygienist for Legionella over there also. So my current, what I do now, my responsibilities as a Legionella hygienist is I conduct environmental assessments and sampling. So when we get a clinical case and we go in and we assess the building, we do an environmental assessment, trying to figure out what went wrong in the building. We do samples, so we pull bulk in swabs and we send them to the lab, and to try to find out the results and try to figure out why the people, why there was an outbreak in a building. When I'm not doing that, I do consulting with our healthcare acquired infection group, and we call these environmental care tours. It's consulting. I walk through buildings where there's no clinicals, and a lot of these buildings are very old, in trouble. And I've walked through brand new buildings that haven't been even opened yet, that I've been asked to consult on. And we're just, they're people are concerned. They want to make sure their water management program is right, making sure that they don't have any issues that could cause them problems. I also educate a lot. So in my winter months, and even now, as I'm doing now, I educate. So I actively travel the state. I'm the only one in the state, so I travel the state. I teach fourth-year apprentices. I do continuing education for inspectors, for plumbers, for the PHCC. I've taught at ASPE and other groups within the state. I also train our DQA surveyors. Those are the ones that are responsible for enforcing CMS. That would be the anybody accepts Medicare money, that gets audited. So I help train their surveyors on water management programs. Again, as Max said, I'm involved in these groups, ASHRAE 514, all these that he previously talked about. I'm a small contributor to all these. There's some wonderful, great mentors, the Janet Stout, Gary Klein, Christoph Loers, Bob Bocock, Andy Jacques, Dan Cole, just some great people out there. I bring back more to the state of Wisconsin than I'll ever give to these things, and we've benefited in the state of Wisconsin for me being networked into these. Again, a lot of very, very great people that work on these. And if anybody's interested and is passionate about this, wants to get involved, reach out to IAPMO or ASHRAE or ASPE. Passive protection against health hazards is the best way to improve population health. Now, I put this in there because we're in the plumbing industry. And in the plumbing industry, this stuff matters. And so the British Journal of Medicine, about 15 years ago, did a survey of the last 167 years, I believe it was. And it was like, what is the number one thing that improved the population's health? And um, beating out antibiotics, surgery, all this miracles of modern medicine, the number one thing was plumbing, was sanitation and drinking water. That was the number one thing that improved the population's health. They said over the last 167 years, what was the number one thing? So we're in the industry, what we do matters. So I'm going to briefly talk in these three parts here about the Legionella disease for those who are on here that aren't quite familiar with it, and then factors that can lead to Legionella growth and spread, and then preventing Legionella growth and spread. So I'm compressing about 3 hours of normally when I teach this to apprentices or when I do continuing education, things like that for plumbers and engineers when I'm on the road. This is a 2 to 3 hour presentation. So Legionella is found in bacteria, is a bacteria found in naturally in fresh water. So it's in the ground, it's in the soil, it's in the water. And there's 60 species of Legionella bacteria. 1/3 of the species cause disease. Legionella can be a public health problem in man-made water distribution systems, in man-made water systems, including fountains and hot tubs and stuff. There are two main types of illnesses with Legionnaire's disease or Legionella. One is Legionnaire's disease and the other is Pontiac fever. Legionnaire's disease is pneumonia, which is cough, fever, muscle aches, shortness of breath, chest pain, headache, confusion, and diarrhea. There's also people that, with Legionnaire's disease, it's all about getting the right, correct antibiotics at the correct time. And if you don't, that's when it becomes a problem. And also there's things called long-term Legionnaire's disease. And so there's Dr. McCoy, Dr. William McCoy, who's part of Phygenics. If you go on YouTube and you YouTube Legionella Dr. McCoy, there's some really good video and on long-term with long-term lung issues that people never get over. There's also been known to have dementia with survivors of Legionnaire's disease. Pontiac fever, there's no pneumonia. It's basically like you feel like you got the flu. Uh, of all the people that are here, it's a good chance that some of the people here have had Pontiac fever. It's just you don't go in and get diagnosed for it. You just feel like you have the flu. Um, Hospitalization, very common with Legionnaire's disease. It's uncommon with Pontiac fever. 10% of the cases of Legionnaire's disease will die, and it's actually higher than that, 10% in the general population. So the general population that are non-healthcare. So basically 1 out of 10, it's like up to like 13%. So 1 out of 10 will die who get the disease. When you get into healthcare, it's greater than 25%. That number is actually pushing 30, 31% now in healthcare associated. So if you're in nursing homes, hospitals, things like that. So basically 1 out of 4 infected will die from the disease. Pontiac fever, fatality is extremely low. How do you get Legionella? How's it spread? By breathing in small droplets of water that contain the bacteria, or accidentally getting it into your lungs from drinking water or chewing ice or having ice. So when we do our investigations, we always take eye samples, and ice can contain Legionella. Ice doesn't kill Legionella, it just encapsulates it. So risk factors. So if you're greater than 50 years old, current or former smoker, chronic lung disease, weakened immune system from a disease, or you're taking medication that weakens your immune system. We find this when Legionella we find it in somebody younger. Usually it's a current or former smoker. It's almost odds are. So it's another reason to quit smoking. So Legionnaire is on the rise. So it's doubled from 2014 to 18. But if you look at this graph here, from 2000 to 2018, it's leaps and bounds. So why is that, right? Well, there's a number of reasons that it is. One, well, they're learning to look for it. There's the UAT urine antigen test that can test for 80% of the legionellosis disease. And hospitals, clinicians, and stuff are learning to actually start to look for it. That's one reason. The other reason, we have an aging population, right? Our 65 and older group of citizens is increasing, and so that's another reason. And just as important, the other reason is our infrastructure is getting older. So everybody in the building that everybody's in right now, the plumbing in your building is as young as it's ever going to be, unless you do a complete tear out, right? So that water distribution system is as young as it's going to be today, and it's going to grow biofilm. And the time I'm done talking today, your water distribution system will have a little more biofilm in it, more than likely. Confirmed cases in Wisconsin. So right now, our average is 227 lab confirmed cases per year. I started doing this in 2017, industrial hygienist. In 2018 was a crazy year. We had a real big spike in that. Otherwise, we're at around 227 per year. Long-term care accounts for almost 50% of what we see for investigations. So long-term care, nursing homes, assisted living, things like that. And then lodging in Wisconsin is 30%. I think nationally, lodging is a little more than 30%, but in Wisconsin, we're about 30%. So hotels, motels, timeshares, we've seen it in. That's where we see that. And then other would be cooling towers, fountains, things like that. They call that community cases. And those are, the others are really hard to crack. That's a hard one to figure out. I've been around crawling in cooling towers, taking samples, trying to figure out where we have community cases, where we have a cluster of cases in a community, and we're trying to figure out what is causing that. We have some great resources. So if you want to Google, or there'll be links here too, but if you just Google Wisconsin Department of Health Services, Legionellosis, you'll find our wonderful page. I had nothing to do with it. It looks really good. Anna and Francis did a wonderful job on this, on these pages and all these links. And there's a lot of links to the CDC, to checklists, there's a lot of good stuff here. So now we're going to talk about factors that lead to the growth of Legionella. So the presence of biofilm, right? every single water pipe is going to have biofilm in it. Like Janet Stouts, there's a party in your pipes, right? There's a biofilm growing with bacteria, Legionella and other bacteria. And every day, like I said before, there's more biofilm growing, and that's the problem is the biofilm. And so the biofilm grows daily, and it's primarily caused by oversized piping that is insufficient for flow velocity to perform self-cleaning. And so the biofilm um, grows daily. So the minute the plumber puts water in the pipe to test the water, even when the sheetrock is not even all up, biofilm is starting to grow. So ideal temperatures for growth and spread. Um, and these I'm gonna go through these temperatures. These are lab conditions, okay? And I got to stress that. So lab conditions. So below 77 degrees, Legionella is dormant, but still viable. It still can get you sick. Um, and then it's in the general growth zone of 77 to 113. That's when it amplifies, when it grows. It peaks between 95 and 99. Legionella loves 98.6 degrees, right? That's why it really amplifies fast when it gets into your lungs. It just loves that temperature. Um, and then at 122 degrees, it starts to decline. It still can grow up to 122 degrees, but at 122 degrees in the lab conditions, Legionella starts to decline in 2 hours. At 140, it'll decline by 90% in 2 minutes. And at 158 degrees and above, it the water becomes a disinfectant, basically, again, in lab conditions. And this is something I'm going to stress. So lab conditions. So now Germany has done some tests, and that's the advantage of being on ASPE and IAPMO and all these groups with these wonderful people on it. What they're finding out is that Legionella is encapsulated in biofilm, and it's inside amoeba, and it's inside the biofilm. And they found in Germany that Legionella can survive in biofilm at 160 degrees for an hour and a half or more, and that's what they're finding. So that's a game changer, right? That makes everybody think now. Okay, and the reason people are thinking is now we have been doing preheat tanks, for example, and these are just questions, not answers, by the way. But like for geothermal, right? And I used to work with geothermal years ago, and geothermal is great and it works and it's an energy saver. But there's preheat tanks that are geothermal that are lower temperature. And they used to have these lower temperature tanks. They still do going into these high temperature tanks, assuming that they'll roll into these high temp tanks and everything will be dead when it leaves. Well, if it washes through fast in biofilm, is it carrying in, downstream of the water heaters seeding the system of the building? We need to find this out. Don't, again, these aren't answers, these are questions, but these are things that they're starting to find out. Europe does a lot of great stuff, and there's a lot of good information comes out of Europe. So other ideal conditions is dead ends, right? We see a lot of dead ends. That creates stagnant water, which on the right we look at an expansion tank, right? And this, you look at this expansion tank on the right hand side. It's this dated April 2010. I was in there last year, so the water in that tank is 13 years old. And that 13-year-old water was the smoking gun in this building. This tank was getting people sick. All right. And that's the problem with expansion tanks. And so these kind of tanks are no longer allowed in Wisconsin, and we'll talk about that later. But that's just dead water. From our colleagues that we work with in Australia, they have a definition. They call that dead water when there's a hard cap, like on the left, hard cap pipes. I also look for cross connection. So that big circle on that piece of equipment on the left-hand picture is a wheelchair washer. When I walk through buildings, I also look for cross connection. When we talk about high surface area to volume ratios, so that's just talking about oversized pipe, Hunter's curve, 1940s. We're going to talk about that in a little bit. But when you have large pipe, and you're only running 4 labs through a 2-inch pipe, that's the only thing that's on, that 2-inch pipe, really, there's going to be no velocity in that pipe. Now when it gets to the 1/2-inch pipe, it's starting to move fast. Other things is low or absent residuals, right? Is the municipality where you get your water provide disinfection, and then the time it gets through your building, are you running enough water to even get any residuals through it? That's one of the things I check as I test for residual in the beginning of the building, and then how far it makes it through the building. And most of the time in these buildings, it doesn't get very far. So we could have, zero point 0.4 parts per million of free chlorine, and the time we get to half, on the second floor, it's gone. There's nothing left. It gets chewed up by the water heaters and just by the biofilm within the piping. I got a quote from Andrew Jacques. I actually talked to Andy. He's on these committees with me, and I said, Andy, can you give me some quotes here? And the reason I asked for quotes from Andy is this way. The feelings of like everybody that's on these committees that is passionate about mitigating Legionella is is we're all kind of thinking the same thing. And I wanted Andy to give me some quotes just so it's not some guy in Wisconsin talking about this. It's basically how the industry thinks, as a whole. Everybody has a little twist to it, but his is, water quality investigations generally finds that a system with Legionella positive test has a biofilm issue that is not properly managed. And I think everybody would agree with that. How does Legionella grow and spread? Aerosolization, right? You're standing in the shower, you're breathing this in. If there's bacteria, what? It's in your lungs, right? And your lungs are at 98.6. Guess what? That's a great place for Legionella to grow. I can't go through all these because of time constraints here, but cooling towers. These are where Legionella can grow and spread. Cooling towers, decorative fountains. We still see decorative fountains getting put in healthcare. uh, Expansion tanks, hot and cold storage tanks. I see cold storage tanks in boiler rooms in hospitals. Drives me crazy. Hot tubs. Just got done with an investigation. A hot tub at a hotel had Legionella in the filters, and they had to rebed everything. And so, like I said, ice machines, water heaters, water filters. And so now, what are the other factors? So there are internal and external factors that can lead to the growth of the building water system, Legionella in the water system. And so you have biofilm, which I talked about. It's just growing continuously. We have construction. And and all this stuff that I'm talking about should be in a water management program. And I do teach water management programs, and there's some water management program presentations that are archived in a Department of Health Services website. But I could talk for 2 hours on water management programs. But water management programs should contain a lot of what I'm talking about. And so construction in the building, right? So it's not just plumbing construction. It's like, say, heating, ventilation. So if they're putting in ductwork next to a water distribution, a hot water line, and they're disturbing, they're vibrating, banging into it, disturbing that line, you could get a sloughing event. And so that sloughing event will release bacteria and can overwhelm and seed the system and cause an outbreak in the building. It can and has in the past. And then inadequate disinfection, what we talked about, the water temperatures we talked about. pH is important, and that just pH matters as far as how the disinfectant works. Just like a public swimming pool, pH tells you how the disinfectant can work. Scale and sediment, that's going to be places for the bacteria to hide. Water age, again, that's the villain. Water age is the villain in this whole thing. Water stagnation, water age creates the biofilm. That's the big issue. And then we call about dead ends and dead legs, and then we have, what's hard cap pipe, which we call just regular dead ends with dead water. And then we have functional dead ends, which are fixtures that aren't used. And that's a big problem I see all the time. So hot water circulation. So, in Wisconsin, for healthcare, water has to circulate 24/7, can't shut down. Now, I know there's a contradiction to the International Energy Code on that, but the Wisconsin Plumbing Code trumps that, and you can't shut these circulators down. But part of what circulation is too is to make sure they're actually working. I've gone to hotels where we were doing investigations, and the circulator's not running, and so I don't know how they've managed not having complaints on the third floor that the hot water's not getting there, but the circulator's not working, and now you have all that volume of tepid water. that can create Legionella and seed the system. So is checking the circulators part of your water management program? We're looking at this here. This is for a combined water system, right? It's combined coming in, so it's feeding the fire protection and the domestic, so it's sized for the fire protection as it should be. Well, you're looking at this setup here. This caused a fatality in a building. So this again, all the stuff I'm saying, most of the stuff that we see could be avoided with water management programs that are implemented correctly. So we have the mechanics came to work on the fire protection. Upstream of this wasn't holding, wasn't working, and so they had to take out the valve and they had to replace the valve. Well, they had to shut the whole building down in this healthcare facility, and by doing so, they caused assumed that they caused a sloughing event. And when the sloughing event happened, then it washes into, and it was an older building, and it was a very old building, so it washed into low temperature water heaters and a low temp water distribution system, and they had an outbreak in the building, cost somebody their life. Now, had they had a water management program, if a mechanic shows up in a non-emergency and says, we're going to shut the water down, the right answer is, we're not ready, go home. You know, we can't do it. We need to have point of use filters. We got to have bottled water. We got to get a flushing program. We have to have extra staff. I mean, there's just a lot of things that need to be done when you start disturbing that water distribution system to keep your people safe, the residents and employees, patients in a building safe. Other things, hitting piping, here we're talking about dead ends again, and hidden fixtures and hitting. We see this all the time when we go into these old buildings. There's just a ton of fixtures. Again, they're creating problems. This is another thing that actually caused a fatality in a building. So there's multiple things that went wrong here. So feeding these two water heaters was a ultraviolet light system that was incorrect, was not of something that would be approved, and didn't have a fail-safe valve on it, so it failed. Water kept on running, and then at some point, this main mixer stopped. So these water heaters were at 140 degrees, and the main mixer to cut this water down to 115 degrees failed. Well, somebody with good intentions, not knowing, and had there been a water management program, this again probably would not have happened, is that they've seen two heaters sitting at 140 degrees, and they go, we never use that much hot water. We're going to turn these, we're not going to fix this valve. We're just going to turn these water heaters down to 115 degrees. And they did. And guess what? They never ran out of hot water. But guess what? They had Legionella blow through the building, right? And so these water heaters now became amplifiers, and it became a problem. So had they had a water management program, maybe there would have been one, temperature should have been a checklist item that you checked weekly, or twice a week, or whatever it should be, and temperature would be checked, and maybe these water heaters would have been placards saying that they shall be at 140 degrees. In Wisconsin, in healthcare, water heaters have to be at 140 degrees now. Here's other issues. We have multiple heaters, redundancy, and one of these water heaters goes down. That's an issue, because the electronics go down on these things. They're not firing, but they leave the tanks in line. And now all of a sudden we have 100 gallons of tepid water within the system. That creates a problem. Fix them or valve them off without creating a dead end, or get them out of there. But the best is to fix them, get them going. Don't create problems. This is all part of a water management program. Ice machines. Ice machines are a food. Ice machines cause issues, and inside of ice machines there is a compressor with a lot of hot air blowing around, and a good opportunity for Legionella to start growing within the ice machine, and then it gets encapsulated in ice. Here we see is a biohazard room. It's in a building, and this is typical of what we see when we do investigations. We call these functional dead ends. Water probably has been running these things for years. There's a bedpan washer next to these where the trap was actually dried out. So this creates problems. This creates a lot of bacteria in there. Matter of fact, this building, we couldn't do qPCR sampling at that point, but they were trying to do grow culture plates we had so much overgrowth because there was so much bacteria in this water distribution system. It just was everything. There was a huge party going on in these pipes here, and it just creates for a sick building. They need to run water through these buildings. When I get done when I walk through a building, part of what is found out is that they end up using more water and more energy when I'm done. And I know that's contradictions to the energy code and stuff, but when you talk about life safety, health issues, it's a big deal. Again, a shower, unused shower, use the storage. Here we have a mop sink. A mop sink, so it's a functional dead end. Well, it needs repair. And they say, well, Bruce, we don't use it. Why do we want to repair it? Well, you need a flushing point. Well, we'll tear it out. No, don't tear it out because now you're creating a dead end. If you tear it out, you got to take all the attending piping with it. So, and in Wisconsin, you can't create dead ends in healthcare. There's a code for that. Again, we have some wall hung sinks that were taken out and just hard capped. Again, dead water. Our colleagues in Australia, they have a name for it down there. They call it dead water. Uh, we talk about external factors. We got changes in municipal water. So Flint, Michigan, right? Flint, Michigan, change in municipal water. They had lead issues, but they had Legionella issues. They had fatalities from Legionella. How did that happen? They went, or the water change caused sloughing events and it exposed a lot of the biofilm exposed or sloughed and released a lot of bacteria. We also have construction. We have vibrations going on outside. So your building is shaking because they're working on the parking lot. Well, the water management program better address that, right? You have water main breaks. Well, water main breaks. Water's going out, but it's sucking debris and bacteria, and importantly too is they're sucking into the water main. They're also food for the bacteria. Uh, when you obtain a Legionella positive test, it is usually the symptom of a larger problem. That's from Andy Jock again. And that's true. And I think nobody would really disagree with that. And then contributing factors. This is from ASPE. ASPE has the Legionella design guide. I'd recommend people get that if you're into any kind of design work for healthcare or any kind of buildings to prevent Legionella is the Legionella design, or excuse me, the ASPE Legionella design guide. So here, this is just representing, you have water temperature, water age, disinfectant residual, um, surface area, for in your pipes. Again, that's coming to pipe size, the nutrients in the water, the type of fixtures you have. These are all related. You can see the arrows going back and forth. You change one, it affects the other. So this is all why this stuff is complex. Now we're going to talk about preventing Legionella growth and spread. So Andy Jock again says biofilm control minimizes microbiological influence corrosion and the potential for Legionella to be present and generally improves water quality in buildings. And that is true. And you're going to find leaks, and that's part of what Andy does. There's Bob Bocock out in California. There's other guys now that I can't think that they do these kind of investigations because there's corrosion caused by bacteria. We're not even talking about Legionella anymore. You can have bacteria mining for minerals in the piping system and causing leaks in your water distribution system. And so that is part of what a lot of these scientists do, like Andy and Bob and others. So what is a water management program? Water management program is the risk management plan for the prevention and control of legionellosis associated with building water systems. It started with ASHRAE 188 and Standard 12. That's from ASHRAE. That's the parent material. And from there, CDC has created a book that's free to get online. And it's developing a water management program to reduce Legionella growth and spread in buildings. So it's just taken what's out of 188 and helping you put it into something that you can actually write a water management program. Uh, what buildings require a water management program? ASHRAE in 188 says any building inhabited by humans. It's not just healthcare. It's not just complex water systems. It's, every building should have some kind of a water management program, whether it's written or unwritten. Even in your own home, right? If you're gone on vacation for 2 weeks, you come home, your water management program would be you're going to flush everything before you use it. There's another great, this is fairly new. This is from the CSTE. This is the Council of State and Territorial Epidemiologists. And this is a good evaluation tool for water management programs. I recommend that you look at this. It's a really, really good and fairly new document. Gaps in water management programs. Well, one is that there's no water management program in place, which is a lot of what I see when I do in my investigations or when we do our walkthrough consulting. Implementation deficiencies and then content deficiencies, right? That's why we have checklists, right? If you go through the checklist, the CDC has checklists too. If you go through the checklist, that'll help you tell you if you have a good water management program or not. Oh, there's also vendors that'll actually consultants that do this professionally. They'll have their own platforms for water management programs, so you can hire them in, and they can come in. Large hospitals and such will do that. Anybody can hire these consultants. They have their platforms. Some are better than others, and they kind of fill in the blanks and they help implement it, and they're help you come up with plans. So there are some very good consultants out there. But we also have some other gaps, and that's process failure, and that's about 81%. A process failure, I talked about temperatures before, right? And a process failure would be in your water management program. You don't put in there checking temperatures. You're not checking your water heater temperatures or your distribution temperatures and where they should be at, right? That's a process failure. It's not even written into the water management program. Human error would be the 2 times a week that somebody's supposed to be checking temperatures is right around their break time, and instead of checking temperatures, they take a longer break. That would be a human error. And then, of course, equipment failure would be the failures of the water heaters to deliver the right temperature, electronic thermometers drifting, things like that. Um, General rules for Legionella prevention. Now, I stole this from somewhere. I'm not sure who I got this from, but it's so true. And it's keep the hot water hot, keep the cold water cold, and keep the water moving. And you keep it moving by using it or dumping it down the drain unused. And I know that flies in the face of energy conservation, but when you're talking about the health of buildings and especially in healthcare, the health of the patients within, you got to use the water. And like I said, part of when I talk and I do these walkthroughs, I tell them their water bill is going to go up and their energy bill is going to go up because they're just these buildings just are designed 1940s, and they still are. Unless you're using the IAPMA water demand calculator for one multifamily, everybody's using Hunter's curve in the country. So again, water temperatures, very, very critical. That's why we check water temperatures. You get into that growth zone, things amplify, things go wrong really fast in that growth zone. But you also have in healthcare, you have anti-scald regulations, and you got to prevent Legionella, right? It's not easy, but it can be done. That's why not everybody does it. That's why we have professionals doing this. So in Wisconsin, October 1st, 2023, the Department of Safety and Professionals did a code update. Well, I got here is some of the healthcare things that were new to the code as far as addressing healthcare in Wisconsin in the plumbing code. Now, I worked at DSPS for 15 years. I was actually part of the committee that was doing these. I left before it was completed, but I was part of the doing this. So that's how I know so much about what's going on here, and it's a lot of good things that the staff and the department did. One is, spouts shall have laminar flow, right? Laminar flow delivers a clear and non-splashing stream without adding air to the water system. Why do you want to have bubbles in a healthcare facility, right? Why do you want to have aerosolization? It doesn't make sense. Laminar flow, that's what infection preventionists, that's what they want also. You don't want aerators. So they're not allowed. So if you're, from now on, you got to have laminar flow. If you're taking out and replacing valves or faucets, they got to have laminar flow. Here we talk about self-closing faucets, which could be the electronic eye, and there's other types of self-closing faucets, but they're usually a problem because they run for 3 seconds, they're not set right. So now they're codifying, so when you have a self-closing faucet, when you turn on a self-closing faucet, when it's triggered, the water shall be calculated to evacuate the water distribution piping from the faucet to the recirculated hot water supply in healthcare. You just can't have that dead water laying around, or it's basically a functional dead end when these things don't work. Other thing is water heaters shall be initiated and stored at a minimum of 140 degrees. So all water heaters in healthcare have to be 140 degrees when they're idling. In Wisconsin, they since May 1st, 2003, so 21 years now, it's been required that hot water distribution systems have to have bacterial control or disinfection in the hot water distribution system in healthcare. And so that is required. And so when that is being required, now they say when you're circulating the water, when you're using thermal as a means of disinfection in healthcare, that you can't have the amount of uncirculated hot water is 3 feet. So you got to circulate within 3 feet of the fixture. Again, we're trying to keep the water moving. And then hot water distribution systems may not include heat recovery systems, because we talked earlier, about, the study in Germany. Well, this is something that we found that some of these heat recovery systems deliver such a low temperature in these preheat tanks were causing trouble. Now in Wisconsin, of course, the code is petitionable. So if you have a hot water distribution, or if you have a heat recovery system that is delivering very hot water and you can prove equivalency, I mean, you can definitely petition the code and use the heat recovery system. Other things besides thermal that we allow, that's we're again required to use a bacterial control for healthcare for the hot water distribution system. So besides thermal is 0.5 residual chlorine at the distal fixtures. We have chloramine and we have chlorine dioxide that is allowed.
I think we may have lost your audio, Bruce. Kevin, did you lose that as well?
Balanced.
Oh, there we go.
Oh, can you hear me?
I can hear you again.
Oh, did you lose me for a while?
Just for about one slide. So I think that sounds like we're back now.
Okay, so you may not have functional dead ends anymore in the healthcare facility, or you may not have any dead ends, sorry. So dead ends, 6 pipe diameters. They also put in water management programs are required in healthcare facilities. And so here it's at 250. In my opinion, you could take a 0 off that, make it 25, or even less. Every building should have, especially healthcare, should have a water management program. Part of what it's balancing valves is required, and our report is required. And this should be all for all healthcare. This should be for all buildings. IAPMO is working on this right now with their hot water recirculation task group. Buildings aren't commissioned correctly or at all. When I go into buildings, I'm finding these buildings aren't balanced. It takes like 14 minutes to get hot water to a fixture. Obviously, it's not balanced, and even new buildings aren't balanced correctly and designed correctly. And IAPMO is working on that right now. There's a task group that just started up that's working on that. But please make sure the buildings are commissioned. Expansion tanks. So we talked about this earlier. So expansion tanks installed in the hot water distribution system shall be of the flow-through type. So on the right is the conventional expansion tank. It's the dead end. On the left is the flow through. So as the water is flowing through and temperature increases, it can expand outward within the tank while flowing through. TACO was kind enough to let me use some of their slides here. So TACO makes a flow through expansion tank. It has a dip tube in it. Again, this stuff has been out on the market. They didn't make this stuff because Wisconsin had the code. By the way, Wisconsin is the first in the country to require flow through expansion tanks. But it just talks about it keeps water moving through the tank as it expands. I put this slide in here is this piping diagram. And we talk about water sizing. So here on this piping diagram, we talk, they're saying 100 gallons per minute is code predicted going through. Well, we know we're never going to hit this. One thing I just beg everybody to do for complex water distribution systems and especially healthcare is figure in the cost of a flow meter. There's really no reason you shouldn't be able to do that. And if you get like an ultrasonic meter, you can put that on and you can actually find out what your peak flows are on your hot water. And you're going to find that you probably don't even need to have that bypass open if it's code predicted at 100 gallons per minute. And the reason I say that is because if you don't get enough water through a flow through expansion tank, now you're creating another problem, possibly, potentially. So, uh, these water distribution systems, especially healthcare, these complex ones, there's no reason that you can't build in flow meters into the cost. Again, purge tanks, these flow throughs. It's also a requirement. So in ASHRAE 188, you're not supposed to have no flow or low flow portions of piping, right? So this helps eliminate that. Again, I mentioned it's Wisconsin legislation. It's the first state in the country that's done this. Now, other countries may have done this, and I'm assuming so because they're making these tanks long before Wisconsin put this into code. And I'm not going to go in just because of time, but here's the ASPE Legionella Design Guide. I recommend if you're doing design work that you pick up a copy of this. They're working on it right now. It's going to be updated this spring. But it's a really good design guide. And if you're working with complex water distribution systems to help mitigate Legionella, I would recommend this ASPE document. Again, we talk about hot water, water age, pressure design, all these things that are important. Here's one that I'm proud of that IAPMO did, and this is the construction practices for potable water. This provides education and guidance, for those responsible for the construction and design and commissioning of water systems to reduce the likelihood of contaminating plumbing systems during construction. Again, how I said, the minute there's water in that pipe, it's growing biofilm. New buildings from day one, can be a problem. Google Miami, Ohio. There's a hospital in Miami, Ohio, probably 15, 20 years ago now. The first months after this hospital was open, they had Legionella blow through it. It can happen. So here's just a table of contents. And the reason I'm just putting on there is it's some really good information in here. And they have construction management during construction tables. They have tables about initial flushing, routine flushing, supplemental flushing. They have these tables for flows to achieve 5 feet per second. Why do we want 5 feet per second? Because we want the kinetic energy in there, to disturb the piping or to disturb the biofilm to get all that water out. That's why you want to have, achieve these higher speeds for flushing. And then, there's more of these flushing tables in there. Cause of water flow, low flow, is lower than desired flow velocities that are caused by plumbing code that does not recognize the decreased flow rate created by the water efficient fixtures. That goes back to what I talked, Hunter's curve, and all buildings are pretty much built and designed to Hunter's curve, except if you're using the water demand calculator from IAPMO for a multifamily. And I know IAPMOs, I'm on the task group, we're trying to bring that into healthcare. We're trying to make calculators for different types of healthcare. Long-term care, hospitals, they're all going to be different. One thing though is when we talk about fixtures now, we talk about, and I'm gonna, I learned this from Gary Klein, one of my mentors, and I'm gonna probably say this wrong, but we have fixtures now that are legal fixtures, right? And they're a lot different than what the fixtures were when maybe the building was originally built. And these legal fixtures are set by the EPA as maximum flow rates, okay? And so the maximum flow rates that are allowed now are a lot different back when we were designing these buildings. And then even now when we're designing buildings now, they're designed to the 1940s when we were water hogs. So we don't have right size piping in a building yet, unless you're using the water demand calculator. One thing that I would beg you is please, especially in healthcare, is don't use quote unquote now energy efficient. So code compliant, would be the EPA maximum flow rate. So if the shower is 2.5 gallons per minute, max allowed maximum flow rate, please don't put a 1.5 gallon or 1 gallon a minute in a old building for a healthcare. You're going to make a sick building. You're going to put people's lives at risk. Don't do that. I know that flies in the face of energy conservation, but it is again, keep the hot water hot, cold water cold, and keep it moving. You got to keep water moving through these buildings. Energy saving fixtures are just going to make people sick in the buildings, or could potentially. It's also created, low flow is by owners for future expansion, the upsize for future expansion that usually never happens. I've seen that a lot. Oh, we're going to add on, and then they never add on. I've seen that. I've gone by buildings, 20 years later, and they've never done it. 30 years later, because I was part of that when I was out in the construction, and the expansion never happened. Don't do it. And I've seen a lot of designers they'll upsize even if they're not doing an expansion. They just want to make sure they never run out of water, so they'll start upsizing everything. Please don't do that. Everything's oversized already. You don't need to do it. Here's just some industry standards. This isn't codified, but Chicago Faucets is one brand. I know Kohler's working on this. These are auto draining shower valves. So in a hospital healthcare, there's no reason these shouldn't be uh, designed into healthcare, self-draining. And now the drop ear, that's all dry. And then they also have it for when you have hoses. Everything drains dry. Like I said, Chicago's one brand. There's other brands out there, but this is the industry standard. If you're designing these things, and you're not, um, and God forbid, you're designing a building that later has Legionella go through it, you may be asked why you didn't put these in. Okay, Legionella is getting to be very litigated. So, you need to do this is kind of the industry standard. Even though if it's not required by code, you should be putting these in. Again, from ASPE, because of time, I don't have time to go through these. Again, this is a good slide here for the water demand calculator. So the red is uh, what the UPC code predicted would be, and it could be no different than the IPC or the Wisconsin code. They're all going to be similar. The blue dots is what the water demand calculator from the UPC says the building would use. So if your state allows you to use this for multifamily buildings, that's what the gallons per minute would be. And then the black dots is actually they metered these buildings, and that's actual use. So you can see the spread between actual use and code predicted. Again, it's a big spread. So the Hunter's curve overestimates water demand. And then here's just a snapshot of the water demand calculator. Again, the more fixtures you have, the better the water demand calculator works, because your simultaneous use chances of simultaneous use, goes down with more fixtures. So, here you can just see the drastic drop in pipe size. And that's all I have.
That was great, Bruce. So I'll just cover these quickly, and then yeah, we can do the questions. So yeah, if you want to reach out to us about a project, we'll answer the phone. There's our tech support number. We've got an email as well that's monitored by that group. And then we like to hear about your projects on social media. We had many questions, which we kind of anticipated there, and I know that Kevin was answering a good amount of those as they came in. as well. So we'll try and pick a couple to go over here. One of the things that is pretty clear based on the questions before, during, and I'm sure after this webinar is that the energy efficiency, water waste prevention, and Legionella management are different sets of rules to different people. So I don't know if we're going to find a bullseye with that, but we definitely appreciate the research and the work of these committees that Bruce mentioned to try and find something that's reasonable for how we keep the water moving. And just some of those examples that you gave were so common, I think, as far as the abandoned shower and a 2-inch line that's going to a wing of a hospital that maybe never opens because they don't get funding to build that wing or something like that. So really good, lot to digest with this presentation. We will have this as a PDF that you can click on some of those links that were well cited throughout. Anything that sticks out to you, Kevin, that we should address while we're still in the call here?
Yeah, there are some really good questions, and great job, Bruce. Thanks a lot. One of the questions, you may know this because you're a plumber, what's the minimum velocity recommended in a hot water system before biofilm becomes an issue? Or is that too complicated?
Well, it all depends on the material. And so, for example, when you're, because materials, and it all depends if it's copper, PEX, CPVC, they have peak velocities, and then you have continuous flow. So if you're circulating in continuous flow, like for example, PEX doesn't want their, and if somebody from the PEX industry, if I get this wrong, but I believe it's 2 feet per second. So if you're circulating under continuous circulation, PEX, you can't do more than 2 feet per second. Top of my head, I can't remember what copper is, but for continuous flow, that's different. Now, when you have peak flows, and when you're flushing, now that's intermittent. Okay, intermittent's different. So if you can, like the construction practices, they're talking about 5 feet per second. So if you can do intermittent flow, like through flushing, and you can get the kinetic energy up inside that piping, you can start to scour that pipe, maybe remove some of that biofilm and get it flushed down the drain. And more importantly, when you flush, and I didn't mention this earlier, when you do flush, you're getting out the biofilm and the old water and any bacteria that's kind of hanging around, but you're also bringing in disinfectant, and that's just as important.
Yeah, and I think that the number, Bruce, is for PEX at or above 140 degrees Fahrenheit for that 2 feet per second. So, and there are different classifications for pipe, different listings for if 24/7, 140 degree circulation is covered or not, basically. Another question I had that you described a little bit is a sloughing event. So one of the questions that I've heard about Legionella in the past is like, oh, we had Legionella colony forming units that were detected in a test, so we just drained the building. And to me, that first of all, I'm not sure that you ever get every drop of water back out of a building. If you try and drain it, there are going to be some low spots and some places that you won't unless you like pressurize from every faucet back. That's not going to get all the water out. Can you kind of explain in a little bit more detail what a sloughing event means inside of a pipe?
Well, sloughing event can happen, one, like Flint, Michigan, change of water quality, right? All of a sudden, um, there's different water coming in, and the bacteria in the biofilm can't handle it, and it starts dropping off. And then it's exposing a lot of bacteria comes out. Other things that can cause sloughing events is disturbing of the pipe. That can cause it. So the banging, the shaking, that can make it fall off. Depressurizing and repressurizing a pipe can cause a sloughing event. And anytime you have a sloughing event, you're exposing all this bacteria, and that's not good. Now it's moving through the piping system and maybe trying to find some place to amplify, and or does again. All you have to do is get Legionella. If you have a sloughing event and somebody's taking a shower, and then somebody's inhaling this bacteria, now your lungs are at 98.6, right? Perfect temperature for Legionella to amplify.
Thanks. I have another good question here for you, Bruce. What pH level promotes the growth of Legionella bacteria, above or below 7?
I do not have that answer. I know pH has a lot to do with how disinfectant works. So when you have a pH of around neutral, chlorine works really well. But you bring a pH up higher with chlorine, now its effectiveness doesn't work that well. And so it's tougher and tougher for that chlorine to work. Hence, that's why in a public pool, there's a drum of acid and a drum of chlorine they're pumping into the pool at the same time, because that makes the disinfectant work better. When you have chloramines, now the pH needs to be a little higher. And again, I'm not an expert on that. I would defer that you maybe do a coffee with Caleffi with maybe Andy Jacques or somebody who can really drill down on these kind of issues.
I got another question. We'll have this on YouTube as well as a PDF if anybody missed that at the beginning. What do you think, Kevin? Do you have there a good amount that I think that we'll have to spin off and email back?
Yeah, there are some more good questions. Since we're at the top of the hour, though, we will reply to all of those. And thanks everybody for entering your questions.
Yeah, I think we can call it there. Bruce, anything else you want to add to close? We really appreciate it. This is just such a big topic, and the data is helpful to figure out, as your team is doing a very good job of documenting.
Yeah, I guess
to put some actionable plans together.
There's some really, yes, yeah, I appreciate you having me. And again, I'm just a person out in the field dealing with this. There's a lot of really good people out in the industry that work with this. As I stated before, it's a moving target. We're learning more and more, learning a lot from Europe, a lot from Germany. For example, Germany, we talked about combined water services. Germany does not allow combined water services anymore, and it makes sense because it's hard to keep disinfectant going and keep water fresh in a combined water service. Because if you have a 6-inch water service coming in to feed either fire protection, you only may need a hundredth of that for your building, right? And so these combined water services are just creating challenges in buildings. So in Europe, in Germany especially, I know they don't allow those anymore. And so we it's international. We learned so much from our colleagues in Europe, Germany, Britain, all over Australia, New Zealand. We've worked with colleagues there, and everybody's doing good work. And IAPMO and ASPE is doing such a great job of including everybody from around the world into these task groups and committees to try to get the best people forward with the best ideas to discuss. And it's a moving target, and we're going to know more next year than we know this year. It's due diligence, and the biggest thing is keep water moving in these buildings, especially healthcare.
Okay, well, thank you. We will be in touch with the extra questions that we got. Great presentation. We'll get this up on YouTube and send an email to anyone who wants to see the YouTube recording. Thank you again. We'll see you next month.